Here are your updates in the world of technology and science. Researchers at Tufts University have developed an AI-assisted system named Decipher that maps the mechanisms by which tuberculosis drugs kill bacteria, offering unprecedented insight into drug action and resistance. By combining high-resolution imaging with machine learning, Decipher analyzes how individual bacterial cells respond to treatment, enabling scientists to identify effective drug combinations and accelerate the development of new therapies against drug-resistant TB. A new transformer-based AI model called Delphi 2M, developed by researchers at the University of Cambridge, can predict the long-term progression of 1,150 different diseases over spans of decades using electronic health record. By leveraging the architecture of large language models adapted for clinical time series data, Delphi 2M identifies complex patterns in patient histories to forecast disease trajectories with high accuracy, outperforming existing models in both scope and temporal range. The model's ability to anticipate health outcomes years in advance could significantly enhance early intervention strategies, personalized treatment plans, and clinical trial design. Trained on anonymized data from millions of patients in the UK's National Health Service, Delphi TM demonstrates strong generalizability across diverse conditions, from diabetes and heart disease to rare neurological disorders, marking a major step toward proactive AI-driven health. MIT researchers have developed Flow-ER, a generative AI system that accurately predicts the outcomes of complex chemical reactions by combining deep learning with symbolic reasoning. Unlike traditional models that rely solely on data-driven pattern recognition, Flow-ER integrates chemical knowledge and reaction rules into its architecture, enabling it to generalize across diverse reaction types, even with limited training data, and propose viable synthetic pathways for novel molecules. This hybrid approach significantly improves prediction accuracy and interpretability, making Flow-ER a powerful tool for drug discovery, materials science, and sustainable chemistry. By bridging the gap between data-driven AI and expert chemical intuition, Flow-ER not only forecasts reaction products with high fidelity, but also provides chemists with transparent, chemically plausible explanations, accelerating the design of new compounds while reducing costly trial-and-error experimentation. Researchers have harnessed artificial intelligence to accelerate the discovery of an eco-friendly passive cool paint that can significantly reduce building temperatures without energy consumption. By training machine learning models on datasets of material properties and thermal performance, the AI rapidly screened thousands of potential formulations to identify a paint composed of sustainable, non-toxic ingredients that efficiently reflects sunlight and emits infrared heat, keeping surfaces cooler than ambient air even under direct sunlight. This AI-designed paint not only outperforms conventional white cooling paints in reflectivity and durability, but also avoids harmful chemicals like titanium dioxide, which can contribute to urban air pollution. The breakthrough demonstrates how AI can streamline the development of sustainable materials, offering a scalable solution to cut air conditioning use, lower carbon emissions, and mitigate urban heat islands, all while maintaining affordability and compatibility with existing manufacturing processes. Alibaba's shares have surged following a strong earnings report that highlighted robust growth in its cloud computing segment, driven by rising demand for AI services and large language models. The company reported a notable increase in revenue from its Alibaba Cloud division, which has been aggressively expanding its AI infrastructure and offering enterprise clients access to advanced models like Qwen. This strategic pivot toward AI has revitalized investor confidence, positioning Alibaba Cloud as a key player in China's rapidly growing AI ecosystem and helping offset slower growth in the company's core e-commerce business. The market responded positively as Alibaba announced it would spin off its cloud unit into a separate company, a move aimed at unlocking value and attracting strategic investment. Analysts note that the integration of generative AI into cloud offerings has not only boosted customer adoption but also improved profit margins, signaling a successful transformation from a traditional cloud provider to an AI-first technology platform. This momentum has contributed to a significant rally in Alibaba's stock, reflecting renewed optimism about its long-term growth trajectory. Samsung is actively benchmarking the real-world productivity gains of enterprise AI models to determine their practical value beyond theoretical performance metrics. Moving past standard accuracy or speed benchmarks, the company is evaluating how AI tools, such as large language models and generative AI systems, impact actual employee efficiency, decision-making, and output quality across departments like R&D, customer support, and software development. This initiative reflects a broader industry shift toward measuring AI's tangible business impact, ensuring that investments in AI translate into measurable operational improvements rather than technological novelty. By conducting internal pilot programs and controlled experiments, Samsung aims to identify which AI models deliver the highest return on investment and integrate them strategically into its workflows. The findings will not only guide Samsung's own AI adoption roadmap, but could also influence enterprise AI deployment standards across the tech sector. As competition intensifies in the AI space, this This focus on real productivity underscores Samsung's commitment to deploying AI solutions that enhance human capabilities while maintaining efficiency, security, and scalability in enterprise environments. Huawei has unveiled a comprehensive open-source AI development roadmap, outlining its strategy to expand its Ascend AI ecosystem through greater collaboration, transparency, and community-driven innovation. Central to this initiative is the continued enhancement of MindSpore, Huawei's open-source deep learning framework, alongside tools for model development, training, and deployment optimized for its Ascend AI processors. The roadmap emphasizes interoperability, developer support, and the release of pre-trained models to lower barriers for enterprises and researchers adopting AI on Huawei's hardware, especially in regions seeking alternatives to Western-dominated AI platforms. This move signals Huawei's ambition to strengthen China's technological self-reliance while fostering global participation in its AI stack amid ongoing U.S. sanctions. By committing to open standards and open-source contributions, Huawei aims to accelerate AI adoption across industries like manufacturing, healthcare, and smart cities, positioning itself as a key player in the next phase of AI infrastructure development. The roadmap also includes plans for developer training, certification programs, and partnerships with academic institutions, reinforcing Huawei's long-term vision of building a resilient, homegrown AI ecosystem with international reach. Google DeepMind has introduced two new AI systems, Gemini Robotics ER 1.5 and Gemini Robotics 1.5, designed to dramatically enhance robotic capabilities through advanced reasoning, perception, and real-time adaptation. Built on the multimodal Gemini Foundation model, these systems enable robots to understand complex instructions, interpret diverse sensory inputs including vision and language, and execute multi-step tasks in dynamic, real-world environments with greater autonomy and precision. Gemini Robotics 1.5 focuses on general-purpose robotic intelligence, while the ER Experience Replay variant incorporates memory-augmented learning, allowing robots to refine their performance by recalling and reusing past experiences. This breakthrough represents a significant leap toward versatile, general-purpose robots that can operate effectively outside controlled lab settings, such as in homes, warehouses, or hospitals. By integrating large-scale AI with embodied intelligence, DeepMind aims to overcome long-standing challenges in robotics, including task generalization, error recovery, and human-robot collaboration. Early demonstrations show robots successfully completing tasks like sorting objects, following nuanced verbal commands, and adapting to unexpected obstacles, highlighting the potential for these models to accelerate the deployment of practical, AI-powered robotics across industry. The concept of AI-powered digital twins is rapidly advancing, with new applications centered on predicting robot failures and optimizing industrial processes in real time. By creating dynamic virtual replicas of physical robots and production systems, these AI-driven twins continuously ingest sensor data, operational logs, and environmental variables to simulate behavior, detect anomalies, and forecast potential malfunctions before they occur. This predictive capability not only minimizes unplanned downtime but also extends equipment lifespan and enhances safety in manufacturing, logistics, and autonomous systems. Beyond failure prediction, AI digital twins are being used to fine-tune workflows, test process changes in simulation, and recommend efficiency improvements without disrupting real-world operations. Recent advancements integrate large language models and reinforcement learning to make these twins more adaptive and interpretable, enabling them to explain their predictions and suggest actionable insights. As industries push toward smarter automation, AI digital twins are emerging as a critical bridge between physical infrastructure and intelligent decision-making, transforming maintenance from reactive to proactive and unlocking new levels of operational resilience and productivity. NASA has marked a significant milestone in its Artemis program as a private lunar lander, developed by Intuitive Machines and supported by NASA's Commercial Lunar Payload Services (CLPS) initiative, successfully touched down on the Moon. This achievement represents the first U.S. soft landing on the lunar surface since the Apollo 17 mission in 1972, and the first ever by a commercial spacecraft. The lander, named Odysseus, delivered a suite of NASA science and technology payloads to the Moon's south polar region, an area of high scientific interest due to the potential presence of water ice that could support future human exploration. The successful mission underscores NASA's strategic shift toward partnering with private companies to reduce costs and accelerate lunar exploration. Despite minor challenges during descent, including a last-minute switch to a backup navigation system, lander transmitted valuable data and images from the surface, validating new technologies for precision landing and autonomous operations. This mission not only reestablishes U.S. presence on the Moon, but also paves the way for upcoming CLPS flights and eventual crewed Artemis missions, bringing humanity closer to sustainable lunar exploration and, ultimately, missions to Mars. A new study suggests that consuming more fruit, particularly those rich in antioxidants like berries, citrus, and apples, may help shield the lungs from the harmful effects of air pollution, with the protective benefits appearing especially pronounced in women. Researchers found that higher fruit intake was associated with better lung function and reduced inflammation markers among individuals exposed to elevated levels levels of pollutants such as PM 2.5 and nitrogen dioxide. The antioxidants and polyphenols in fruits are believed to counteract oxidative stress caused by airborne toxins, thereby mitigating cellular damage in lung tissue. The gender-specific effect may be linked to hormonal differences or variations in how men and women metabolize antioxidants, though further research is needed to confirm the mechanisms. Nonetheless, the findings add to growing evidence that diet can play a crucial role in environmental health resilience. Public health experts suggest that increasing fruit consumption could be a practical, low-cost strategy to bolster lung health in urban populations frequently exposed to poor air quality, offering a dietary complement to policy-driven efforts aimed at reducing pollution itself. A recent study has found that higher fruit consumption may help protect the lungs from damage caused by air pollution, with the benefits appearing to be particularly strong in women. Researchers observed that individuals who ate more fruits, especially those rich in antioxidants like vitamin C, flavonoids, and carotenoids, showed better lung function and lower levels of inflammation, even when exposed to high levels of pollutants such as fine particulate matter PM 2.5 and nitrogen dioxide. The protective effect is thought to stem from the ability of these compounds to neutralize oxidative stress and reduce cellular damage triggered by airborne toxins. The study highlights a notable gender difference, with women experiencing greater lung protection from fruit intake than men, possibly due to hormonal influences on antioxidant metabolism or differences in body composition and lung physiology. While the findings don't negate the urgent need to reduce air pollution at its source, they suggest that dietary strategies, particularly increasing fruit consumption, could serve as an accessible, complementary approach to safeguarding respiratory health in polluted environments. Public health experts are now considering how to integrate nutritional guidance into broader environmental health recommendations, especially for vulnerable populations in urban areas. Researchers have discovered that AI creativity, the ability of large language and generative models to produce novel, coherent, and sometimes surprising outputs, is not a carefully engineered feature, but an emergent, almost inevitable byproduct of the underlying architecture. By analyzing how transformer-based models process and recombine patterns from vast datasets, scientists found that the very mechanisms designed for prediction and generalization naturally give rise to behaviors that mimic human-like creativity, such as generating original stories, composing music, or proposing unconventional solutions to problems. This insight challenges the notion that creativity in AI requires explicit programming or special modules. Instead, it arises organically from scale, data diversity, and the model's capacity to interpolate between learned concepts. The findings suggest that as AI systems grow more sophisticated, creative outputs may become increasingly common, even unavoidable, raising both opportunities and ethical questions. Understanding this phenomenon could help researchers better control, evaluate, and harness AI creativity, while also shedding light on the nature of creativity itself, blurring the lines between algorithmic pattern matching and genuine inventive thought.